And now, dear grade 11 students, we reach the last part of our videos about derivatives and the domain of definitions of the function and its derivative. Here is a function f of x that's equal to 2x to the power 4 plus 2x multiplied by radical x. So it's clearly that it has the form of u dot v. We can expand and change into powers, but let's use the idea of the derivative of the function of the form u dot v. Now notice that the domain of definition of this function f is r plus. Why is that? Because no conditions on these, they are just representing a polynomial, while according to this radical x, the condition is that x should be greater or equal to 0. So that's the condition on radical x. Okay, that's the condition on x under the radical. So the domain of definition of f is r plus, so it's written like an interval that's closed at 0 and going to plus infinity. Now let's start finding the derivative of f. U is considered to be 2x to the power 4 plus 2x, then definitely or directly we find u prime, which is 8x cubed plus 2. V is radical x, so u is this one and v is this one. So v is radical x, then v prime is directly 1 over 2 radical x using the rule of the derivative of radical x. Now f prime of x is u prime v plus v prime u. So we just take u prime into v plus v prime into u. So u prime into v plus v prime into u, as if we are making that way. So u prime into v plus v prime into u. Thus we'll get that f prime of x is equal to 8x cubed plus 2 into radical x plus 1 over 2 radical x, which is v prime into u, which is 2x power 4 plus 2x. Now making some calculations by making the same denominator here and multiplying this by 2 radical x and then expanding, we are going to get this result. And that's equal to 9x to the power 4 plus 3x in the numerator and radical x in the denominator. So according to the domain of definition of the function or of the derivative f prime, it is going to be r plus star. It's not just r plus, because 0 is not accepted here because we have radical x in the denominator, and then the condition is that x should be strictly greater than 0, and it's not greater or equal to 0 as the condition here. So here the condition was that x is greater or equal to 0, while here the condition is that x is just greater than 0 without or equal, and that's why we write it in that form, opened at 0 till plus infinity. That's how we write the domain of definition of f prime in the interval form. And here is a link that takes us to GeoGebra to see the representation of these as curves of f and f prime. Let's go. Let's wait for GeoGebra to open, and we are going to see the representations of the graph of f of x and that of f prime of x. Now that is for f of x, the green one. As you see, it is defined at 0. It starts here. So as I told you, the domain of definition was from 0 till plus infinity, and it was defined at 0. That's why we closed the interval at 0. While according to that and that, these are the answers of the derivative of f of x. Now according to that, let's see, it is the blue one that represents the curve of f prime, and it's not defined at 0. Let's make sure if we have to write, for example, f prime of 0, then the answer is, as you see here, undefined, while f of 0 has an answer which is 0. Okay, so that's why the domain of definition of f prime, as I told you, is not opened at 0. It's an interval that's, sorry, it's not closed at 0. It's an interval that's opened at 0, which means that f prime is not defined at 0, and that's the proof using the graph. Now let's move to the 8th example. In this example, we have a fraction form. We have f of x equals to 4x minus 9 over 3 minus 2x. It's in the form of u over v. So there is a condition surely on the denominator. The denominator should never be 0. That's for f of x to be defined, then x should never be 3 over 2. So the domain of f, the domain of definition of f is r minus 3 over 2. And if we want to write it in the interval form, we write it that way. The domain of definition of f is equal to the opened interval minus infinity till 3 over 2 opened union 3 over 2 till plus infinity. So the only excluded value is 3 over 2. All real numbers are accepted except 3 over 2. Now let u be the numerator, which is 4x minus 9, then directly u prime is 4. And let v be the denominator, which is 3 minus 2x, then v prime is minus 2. Now here we apply the rule of f prime of x equals u prime v minus v prime u over v squared. Now u prime is 4 into v, which is 3 minus 2x, minus v prime, which is minus 2 into u, which is 4x minus 9. Making our calculations, we'll get 12 minus 8x plus 8x minus 18 over 3 minus 2x squared, which is definitely minus 6 over 3 minus 2x squared. So that's f prime of x. The domain of definition of f prime is the same as that of f because we still have the same denominator. So the denominator here was 3 minus 2x, and here it's also 3 minus 2x squared. So when we make the condition, we neglect squared and it is just 3 minus 2x should not be 0, then x should not be 3 over 2, which is the value that makes the denominator 0. So the f prime is r minus 3 over 2 also. Now let's visit GeoGebra again to see the graphs, to view the graphs of f of x and its derivative f prime of x, and to see how they are not defined. Both they are not defined at 3 over 2. Here I drew 3 over 2, which is a vertical line, and the purple one is f of x, the graph of f of x. Here it is, sorry. And that's for its derivative f prime of x. That is for 2x minus 3 squared, okay? So as you see, both are not defined at the same value, which is 3 over 2. That's 3 over 2 between 1 and 2. Okay,